All right, guys, we're going to start on lecture. So this is part 3 of our networking unit, part 2 of doing it from scratch. And I will say this lecture has quite a few pretty heavy topics, and you don't need to understand, the ins and outs of everything. You just need to understand at least the level that we're going to be using it. So pretty surface level. But please stop me if you're confused about anything. And a lot of what I'm going to be doing in the demo code, you're actually going to be learning a significantly easier way to do it on Wednesday. So to kind of bring you back up to speed for where we were last time, we had built out, all of the interactions that you need to do on your phone, locally, as if you had a mock API. But today we're actually going to be integrating into a real backend. So I have an API specification for a backend that we're going to be integrating into. And the overview of what routes we're going to be engaging with, there's just, so it's still the same app where we're doing a list of songs. And it's just going to be a route to get all of the songs in the database, a route to update a specific song, and then a route to delete a specific song. And so the steps we're going to have to do is we're going to be creating one request every time we want to interact with the database. We're going to, again, have to set the parameters, so things in the link, and then the content, and then we're going to have to handle results, we're going to have to handle errors, decode responses, and the way that we're going to figure out if there's a server error or not, because there's going to be errors locally and errors on the back end, is through status codes, which are also part of the specification that we'll give you for a back end. So here's just a little bit of preparation that I have in the demo code. So for every request, we have to specify whether it's a get, post, put, or delete. So you just put in a string, and we're going to be using a few of these. So I just put them into an enum so we can easily access them later. But you could always just type them in yourself. It's really just a convenience thing. And then also I created a bunch of errors to kind of describe what might be going wrong in correspondence with what the backend has said. But these errors are very fluid. It can be whatever you want. It's really just to help you debug what's going on, because networking can have a lot of problems. So the first kind of harder topic is something called a result. So we're going to be either returning successful data that we get from our backend, or we're going to be returning an error. And we can't really do that in Swift. We haven't learned how to do that, at least, how to return two different types. And so that's where this result type that we'll be talking about for the next little bit will really help us out. So we've seen these kind of weird brackets before. We haven't talked about them. We've really skirted around them because for the most part you don't really need them. But for today, we actually do need to talk about it. So for those of you who haven't learned any strong typed languages, generics are a way to associate another type with one type or function. And this allows us to reuse a lot of code for different types. So for example, we're going to be integrating with our backend, and sometimes the backend will return a single song, and sometimes the backend will return a list of songs, and we're going to have to be able to handle all of these. And so, as I said, we've actually used quite a few generics already. So some examples are arrays and dictionaries. So on the left, we see an example of an integer dictionary, or an integer array and a string array. So as we can see, it's an array that has in the parentheses an integer and an array that's a string. And we've been writing the types for these as integer with the square brackets around it. But that's really just syntactic sugar for this extra syntax, which says that we are creating some generic class which is associated with integers. So it has an element full of integers. And so, but you can see that the process is always going to be the same. We have all the same operations. It's just the internal type representation is slightly changed. And then for dictionaries, we have it's the same idea, except you have two types. It's a key and a value, and obviously corresponds. But generics are a super loaded topic, and you don't really need to understand anything beyond the idea that we are going to be using generics to kind of represent a lot of different types of code without strictly writing them out individually. So the next thing that we saw is something called an associated value, in enums with associated value. If you take 3110, you'll call this variance. And so here we see a declaration of a type called option, pretty much like optional, except I defined it instead of some Swift developers. So it's an enum with two cases, so none or nil, and then some with a value. And this allows us to, it allows us to associate a value with a case in an enum. So, for example, we could use this type to create, an optional integer or something with none. And you'll notice I have to actually specify what the type is here, which you saw on the last page as well. We don't actually have to ever worry about this because this just won't show up with results. What's happening is, at least with some, you can actually infer the type because we have 3, but if you have none, there's no type, so you have to explicitly say it. But that's not really something you have to worry about. What's more important to focus on is the way that we have kind of said, okay, there's going to be a case, and I want to put in a little bit more information. And this information is going to be some type I'm going to basically be asking someone to assign, help me out with it later. And that's what this generic thing at the beginning is I'm going to name it something random, and you can put it in later and help me figure that out. Does that make sense to people? So handling enums with associated values is slightly harder, I guess, than handling normal enums. It's pretty similar, to be honest, though. So, for example, our none case, which has nothing associated with it, it's the exact same as we would for any other switch statement. But when we do associate a value, we have to give it a name so we can use it. And the syntax that we do this is just we put in a let statement in the parentheses. So it's if we had a sum of 3, it's just saying, okay, I'm going to assign this to be the named value, and then I can use it later. You could also use if statements, except it's called an if case statement. So what it's saying is I'm going to try to bind it to the specific enum case, and if it works, then I'll run some body. So for example, I'm setting my option, and my option is just option.sum of 3, and then it's saying, okay, if you're sum and you have an integer, just print the integer, and this name can be whatever you want it to be. But this isn't something you really need to understand. All you need to really get is how to handle them with switch statements, and then also how to create them. So coming back to where we started, from the result type, result has these 2 associated types, which are success and failure. So some type that's going to be success. So it's either going to be our song or our list of songs, and then some kind of failure, which it has to be an error. That's what this where clause means. But we can just define any error that we want. That's what the error was at the beginning of the lecture. And then we have 2 cases. So it's either a success, in which case it'll present the successful data, or it's a failure, in which case it will tell you why it failed. And this brings us to our next really big topic for today, which is threading. Actually, before I go on, does anyone have questions about results or about enums with associated values? So threading is a really big topic, but it's going to be kind of minor for us. But so a little backdrop of threads, if you haven't really discussed them yet in your classes, is we can split up our work into distinct little processes that can work independently of each other. So they almost run in parallel. If they actually run in parallel or not, it kind of depends on your system, but we can think about them this way. And so everything that we have done so far in this course has been on something called the main thread. And the main thread is really high priority, so it means it will if it needs it, it'll kind of push other threads out of the way, and it will hog, your computer. And it updates your app and handles any user input. So we can imagine this is a really important thread. And if something really expensive were to run on it, like if we were to download a bunch of images or were to sort a really big list or something, you're going to have to wait before your app is updated or any user input is inputted. which is kind of concerning because that means your app's going to freeze. So like, spinning wheel of death on your computer means something has stalled your main thread, and we very much want to avoid this because someone's going to like get mad at your app, they're going to delete it, close your phone, restart their phone, whatever. Not a great scenario to be in. And so since we're networking, this is something that we really have to think about. So here's just kind of a little diagram. Like if we're talking about our table view, we swipe it, and then it's going to have to reload. It's going to have to get some logic to figure out what it wants to reload, and then it's going to have to download the data and decode the data, blah, 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 blah. And this entire time, the phone's going to be stalled, and the user is going to get mad. So this thread, this kind of simplified solution would be, let's recognize that we need to, download some data, but then all the downloading of the data is going to be done kind of in the background. So this will let the user kind of interact with the app while it's still loading. And then we're somehow going to have to integrate the two, which is kind of contradictory to what I said before, where they're independent of each other. But we're going to have to figure out how to integrate the two before we can actually show our data, because only the main thread can show data. It can only be the only thing updating the app. So before we get into some of the nitty-gritty, we're just going to say how you actually schedule a thread, how you schedule some code. And it really just comes down to this one line. This is all you really need to know about threading for this class. And it's just dispatch queue, so it's something that will manage threads. And then you put in main, so you ask for the main thread. And then async we don't really need to talk about, but ultimately it takes in a function, and then it will run it on the main thread. If you want to do background threads, this is the syntax for that. But all of the background thread stuff is handled for us in all of the APIs that we're using. So you don't really need to worry about this. This is just kind of extra if you want to do more stuff. But going back onto how you can reintegrate your data, you can imagine there's a lot of different ways that you're going to need to do this. So it's kind of hard to code in one specific way. And that's kind of been the theme of today, is how can we get as little code repetition as possible, but make it also as flexible as possible in doing so. And the answer to this is something called callbacks. Callbacks, they're also called closures. Really, they're just functions. But the idea behind them is once some process is done, they will call this function for us to let us know that it's done, and will help us reintegrate or resynchronize our two threads. So you can remember all the times where we had to set completion handler to nil. That's because they put forth a contract saying, we're going to do something on another thread, but once we're done, you might want to do something. So please let us know what you might want to do. And then obviously if you set it to nil, it's not going to do anything, but in theory you could. So here's an example of how we could write something with a completion handler or a closure or callback. So this is something we're going to be using in our demo today. It's going to take in our result, right? So the result of our networking call, and then it's going to return nothing. It's only going to change parts of our state, because you're not going to be able to access the result of a completion handler because the result's going to be stored on a different thread. So here's an example. We have a do block. We try to decode some information, and if it works, we'll call our completion handler, and we're going to say, okay, I have to return a result, and the result is going to be a success because we succeeded in decoding it. And then we're just going to pass in the decoded data because that's the result of it. Whereas if it doesn't work, we call completion handler and failure. And so what's important to take out of here is, even if you are failing, you still probably want to call your completion handler. That's why this result is kind of really helpful, because it makes us recognize that we have to do both cases. Does anyone have any questions about that? So you might have noticed this little escaping tag, and that's a little bit of little bit of a hitch that we're going to have to just slightly discuss here. And so this is, imagine that we are downloading some data. We have our main thread, and it's interacting with our user. And on the background thread, we are currently fetching data. And this, imagine that like this is going in chronological order from like a long time ago to soon. So we're fetching data, and then we're done. We're calling the completion handler. We're saying that we're done. We're going to get erased soon, and I want to synchronize our information. So it creates a new call frame for the completion handler because it's calling it. And then the completion handler wants to integrate into the main thread, but then the function, the networking call function, wants to get erased. So the problem is, if it gets erased before the completion handler is done integrating, then there's the only place where the completion handler lives is in the original function call. So once the original function gets erased, so does the completion handler, and so will any side effects that you wanted your app to have. So essentially, you'll be erasing all the work you did, and there'll be no signs of what's going on. So what escaping does is everything's the same, except you can kind of think of this like weak variables when we're talking about protocols, where it says, there's a pointer here, but I actually want these to be kind of thought of as like distinct entities. So I'm actually going to make you wait for the completion handler to be done running before you can erase it. It's kind of its own standalone entity, even though it is kind of called by the networking function. Does anyone have questions about that? Cool. So just kind of a summary of the process of threading that we're going to do is, we're going to start our request on a background thread. We're going to, set up all of our data, our parameters, our content, our request type. We're going to set that all to the backend. And then we're going to retrieve also on the backend. We're going to decode our information, handle our errors, create a result. But then once we want to switch our UI or switch data that the UI depends on, that we have to do on the main thread. So now we're going to get into the demo. And I again want to kind of preface this with, we're going to be using something called URL sessions. But you don't need to know URL sessions. This is Apple's way of networking, but we're going to be showing you a significantly easier version next week. Oh, great. Is the font big enough for people? Yeah, cool. So here is the code that I told you we were going to have. So it's just, a bunch of request types and then some errors. I created a new decoder, and just as you would normally, as I showed in a few lectures ago, but I set the date decoding strategy to be ISO 8601. You don't really need to know what's going on here. It's just kind of a quirk of the background, and you will need to do this when you're decoding stuff in your next project. But you can just do this every time you create a decoder. You don't have to save it. I just didn't want to forget it. This default session is a URL session, so it's not something you actually have to know. And then the API is just a path to the API for songs. So what we're going to be doing right now is creating one function that will handle all of our networking requests, and we'll take in parameters to change certain things. But because there's so much repetition, we really want to do this once so that you don't make any mistakes. So I'm going to make a function. I'm going to make it private. You don't have to do that. And I'm also going to make it static. This is just kind of how I designed this type, but you can really do it however you want. I'm just going to say like network request. And we need a few things for this function to run. So first things first, we just need a route. So what we're going to append to this string to specify what we want. And I'm just going to say by default, it's an empty string because that's just where a lot of the routes are. Next, we need the request type. So whether it's a get result or a get type, a post, put, delete, so request type. And then I need parameters, which I'm going to leave as a list of custom string convertibles You could also do it as a list of strings. And then content. So some requests need, extra parameters. Some of them don't. So I'm going to make it optional. And I'm also going to set it to nil. So by default, I'm going to say that they don't actually need content. And then the last thing we need is the completion handler. So again, it has to be escaping. And it takes in a result. And then it returns nothing. So void. And so the types that we need to specify on this, well, we know the error. It's what I defined earlier, which is a request error. But for the success, we're not sure, because it could either be a single song or it could be a list of songs. So this is where we have to understand generics, because I want it to work on multiple types. So I'm going to make this function itself to generic. So I'm going to call it, say, I want you to tell me a type at some point, and I'm going to use this in my result. And so that compiles. That's great. We will be throwing some errors, so I'm also going to mark it as throws. Does anyone have questions about that? Because I realize this is a lot going on. Okay. So first things first, we're just going to get a URL, so somewhere to do something. So just let URL be a URL, and we use this loadout for a string, which just says use the text to initialize it. So first I need the API, then I need / with the route specification. And then what you'd want is, some stuff about the parameters. And so we could, in theory, have multiple parameters. We're not going to be working with them in this project or in your homework. But for sake of making this more expandable, we're going to say that it is potentially an entire list of things. So I'm going to have to, add these into one string. So I'm going to say this is like parameter concatenation. So it's a concatenation of the parameters. We'll say for now it's just an empty string. And then for every parameter, I'm just going to add it in. So this equals the parameter. And then, of course, we want everything to be enclosed in forward slashes. So I'm just going to put it at the end. And then I can just add it in here. So I'm just going to put another forward slash, and then parameter concatenation. And so there's our URL. This is actually going to be an optional, and I don't want to handle that. So I'm just going to say, if this doesn't exist, I'm just going to return. You could also throw an error. That'll probably be better practice. Once now we know where we're going to communicate with. Now we have to actually tell them how we want to communicate them. So we have to create a URL request, so just a request. But again, the URL request we don't actually have to understand for homework. So request is a URL request. So now we have a request, and we have to set its method. So we have to tell it what kind it is, a put, get, whatever, and just say, so this is pretty easy. We just say request.http method be the request type dot, we're just going to take it from here. So it takes the string out of it. And then we need to set the body. So we've already set parameters, so body's the only thing left. So if the content exists, then I would like to set some information. And so I'm going to say the body, which is just this HTTP body field, is a try. We need it to encode our information. So encode our content. And this could potentially throw errors, but we're not going to handle it. We're just going to let whoever is calling this function handle it. And one quirk of URL sessions is, we've told you that, the gold standard for communication between front end and back ends are JSONs, which for the most part is true. But there are other files or file types, so we do actually have to specify it, and we have to specify it through strings, which is kind of gross. But so what you have to do is request and set value, and we're going to say application JSON for both the content type and then also the accept type. So now we've set all of our prep work. We have our URL, we have our method, We have our body. So now we just have to send our request off and then handle our request. So this, where we actually handle the request is this default session, which again, you don't have to follow along, but I'm just going to create a data task. So this is just one communication, and it takes in the request, and then we will have to build out a completion handler in a second. But this actually returns a task, like it returns kind of a thread, and you have to execute it. So I'm just going to call resume at the end, and so we don't forget about it right now. So this is a completion handler for our task, and it gives us three things. So it gives us our data. This is where our JSON is going to be. It gives us a response, which is going to be the response code, and then it gives us a potential error. And if it's an error, we just kind of want to exit. So we say if there's an error, then I'm going to call the completion handler with a failure. And I'm just going to say uncategorized because, to be honest, we're not really sure what might be causing this, but we can definitely print the error to let us know. So now that we know that there's not an error, which we can assume because the error was nil. Oh, and to clarify, this is an error on the front end. This is on the communication, not the back end itself. If there's a back end error, we will have to deal with that later. So if there's not an error in communication, then we have to look at our response codes to know if this is okay or not, if we had a great communication or not. And for some reason, response code isn't something that's easily accessible. We actually have to cast our response to be an HTTP URL response, and this will give us our status code. So I'm actually going to say guardlet because if it doesn't give us a status code, I have no clue what to do. And so for my else, and I'm also going to make sure that data exists because if it doesn't, I also don't know what to do. In this case, I'm going to again call completion handler. Oh, this should return. And I'm going to say it's a failure, and it's, again, uncategorized because I don't know what would have caused that. Cool. And the reason I'm not throwing in here is because this completion handler isn't allowed to throw. Because of that issue with threading, it wouldn't be accessible to the main thread, so we have to communicate it in a return response. But okay, so now we know we have a response, a status code, and some data, so we can check if it's valid or not. So if we had a successful communication, it's going to be 200. And otherwise, it's going to be some error. So first, I'm going to talk about what we do if it's right, and then we can talk about what it's wrong. So if it's right, we know that we have some information, and we have to decode it. So that decoded data equal try. So we're going to use our decoder, which has the date set, right? And we're decoding on the data. And the type, we don't know what the type is because it can change. So we're going to use this generic type. So decoding type. And then we have to put self because it's a type, not an instance. And this is going to have one slight error. Hopefully it shows up. Okay, sadly it's not giving us a great error on this. But what's really going on is, if you remember from when I talked about codables, for decoder and encoder to work, we have to decode or encode from a codable type. Whereas if here, when we're just saying give me any type, we can't guarantee it's codable. So we can't guarantee this is going to work. And the way that we fix this is by adding something called a constraint, which really just means I'm just going to make sure that it's codable. So you just put a little colon and then codable in our declaration. And hopefully this error will go away. Okay, that will go away in a second. Oh yeah, so since we can't throw here, we have to put it into a do block. Or you could use some other type of try, but I think do block's probably the best here. And then, so now if we can say that it's successfully decoded, then we can just call success. on our data, decoded data, and return. And then if it doesn't exist, I have no clue what happened, so I'm going to print this error. I'm going to call completion handler with a failure, and I created a thing for decoding errors, and I'm just going to pass in the error so we can use it later. And then I'm also going to return, because we can't do anything else if this failed. So now say that we have completed a successful conversation with the backend. We have handled that case, but we haven't caught every other case. So I'm going to say for every potential status code, I want to handle it. So we have a few cases, which are all outlined in the specification. So 404 is the first one. You've probably heard of it. And in this case, I'm just going to say completion handler with again, these are all going to be failures because we had a bad code. And this is just not found. 400 is a bad request. And actually, it's a little more specific than that. We actually have 2 errors that gives you 400, but you don't have to worry about that. And then default, for everything else, I'm just going to say that it's an uncategorized error. And so now we're actually done. We've built out all of our networking that we have to do for this project. We just have to kind of specify certain things. Let me actually pull out the API. Oh, that's not it. So here's the API. So first things first, I said that we wanted an all request. So all this takes is we need to switch to the route to have an all tag and then nothing else. So for get all, I can just say get a new function, solve all songs, and the only thing it's going to need is a completion handler. So another escaping, and it takes a result with the success being a list of songs, and the end result or the error being a request error, and then returning void. And then we just call our network function. And we do need to specify the route, so it's all. The request type is a get. Parameters are null. Content is also null. And our completion handler was given to us. Since I just said try, this is actually going to throw. Throws. And since I don't need parameters, I'm just going to give it a default value of having nothing. And so we're going to write a bunch of like these kind of simplifications for ourselves. And I don't know, I got kind of annoyed of writing these completion handlers because it's a long title. So I'm just going to create a type alias to do that. So I'm going to say let handler with a decoding type, or actually I'll call it a success, be a result, which is with a success of success and a request error. And it's actually a function that will take that and return nothing. And so then if I want to simplify this, I can put it as an escaping with a success of a list of songs. And that's good. So now we can try to integrate that. So here we have a function that asks to get all songs. So we need to call our network function. So network manager dot all songs, and with a completion handler. It's going to get slightly mad at me because I didn't use anything to handle the errors, because this is a throwing function. Catch. And I'm just going to print an error if it has one. And then this is going to give us a result, right? Because that's what a handler is for us. And we have to handle both a success and a failure. So a success. And so we have a list of songs. And this is where the generics really help us out, because we know we have a list of songs instead of something else. So that's songs. And in the case that we have songs, I'm going to set my self.songs to be songs. And if we have a failure, I'm going to just print it out. And this will compile, but it will give us a runtime error. Once it loads. And then if I call it, no, that's not it. That's interesting. So, okay, I guess I kind of designed this class to kind of deal with the threading issue, which is kind of interesting. Which I assume has something to do with this did set, but something that's worrying here is this is all on the background thread. So when we make changes, we need to make sure. Okay, there it is. I don't know why it wasn't reloading before, but it gives you this really scary error. It used to be a lot nicer. It actually used to be really fine. It used to just give us a purple error, say it's fine. But you'll see this really gross error, and somewhere it'll say, modifications to the layout engine must be performed from a background thread, blah, 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 and it should have been from a main thread. So that's just letting us know that, okay, we have made changes here to our main data without making sure that's from the main thread. And the reason that I've changed the UI here is because when I change songs, I've also made it set up to reload my table view. So the way that we fix this is I'm actually just going to put everything in this completion handler to be actually on the main thread, because there's not very much complicated stuff going on here. And then I'm also going to say, once this is done, I'm going to say I want my reload thing to, my refresh control to end refreshing. So now if I refresh it, if it lets me refresh. Okay, great. It works. And I can say that it works because if I run this function, and it will hit the breakpoint, and it'll keep going. So this is basically all of the meat of today's lecture. I'll do another example with delete. But that was kind of a lot. If anyone has any questions about how I use the networking request to make all songs, or anything about this code, now would be a great time to ask a question. All right, so I guess I will just go into how we could do it for a delete. So let's create another function called delete song. And again, I'm going to need a completion handler, which is going to be an escaping handler. And this is going to return a song, and we know that it returns a song because of the API specification. So if I go to delete, return type is a song. We also know that it needs an ID in the parameter and an artist in the body. So I will put those as arguments. So ID is a UUID, and artist is a string. So this throws as well. And then I'll just try network request. It's going to not have a route. It's going to be a delete. It has a parameter of ID. The content, I'm going to make this a little cleaner. The content is just going to be a song with its artist set to artist. And then its completion handler is going to be completion handler. And then if we go over to the delete song, right now I just have the code delete it from a list, but we're going to need to do this from a networking call. So I'm just going to say we're going to try network manager.delete with, I'm going to put it where I've already unwrapped the song and artist. So it's going to be the song ID and the artist. And then for completion handler, I want to, again, set the dispatch queue, or set the thread. and then remove it from my songs, and then return true. And then if it fails, I want to say why, and then just set it to be false. That should... Oh, right. So I actually have to set the result. I forgot about that. So I'll switch on results. Case of success, we'll say let song. And so now that we have a song, we'll check that the ID in our data is the song's ID. And then if there's a failure, we'll print the failure out as well. And in both of these cases, I'm just going to stop execution of this completion block. And now if I delete a song, it deletes. And then if I reload it, it's still not there. So that's everything for today's lecture. I'll be sticking around for questions because I know this is kind of a lot. I don't know if you have anything to add. Yeah. Awesome.